Okay, guys, so for today's lesson, again, we're not really going to do anything super new. We're going to continue with what we talked about yesterday, which is what happens if our roots turn out to be irrational, except instead of leaving them in simplest radical form, we're going to talk about what happens if we have a problem that asks for us to be, ask for the answer to the nearest tenth, or if, let's say, we were doing a word problem where we would need to round our answer to the nearest tenth. So let's wrap up what we did yesterday here. Solve using the quadratic formula. So we're going to say A is 2, B is 1, and C is negative 5. So I've got X is equal to negative B, right? Plus or minus square root of B, which is 1 squared, minus 4 times A, which is 2, times C, which is negative 5. And that's all going to be divided by 2 times A, which is 2. So I've got X equals negative 1. Plus or minus the square root of 1 squared, which is 1. And then again, we're going to be super careful. Negative 4 times 2 is negative 8. Negative 8 times negative 5 should give us 40. Divided by 4. So now I'm looking at X is equal to negative 1 plus or minus radical 41 divided by 4. We can't do anything with that, right? So our radical 41 does not have any perfect square factors. It actually doesn't have any factors other than 1 in itself. So the best we can do is simply leave it as negative 1 plus or minus radical 41, all divided by 4. All right, so again, guys, the only thing we're going to do different today, so this is kind of like a review lesson, is we're going to round yesterday's answers to the nearest tenth. So we're going to take a look at x squared minus 2x minus 10 equals 0. You're going to look back in your notes to what we did yesterday, and you're going to see that when we solved this, right, when I simplified it in its most simple form, we ended up with this. Right, now I believe, and I don't have it in front of me, but I believe what we had originally was this. All right, and then we simplified to get that, and I think we haven't even had, if I'm looking at it again, we had something even a little bit more complicated than that. So if I do my b squared minus 4ac, I actually had this. Now, why am I talking about this? Well, the reason I'm going into all of this is because they're all the same, right? Mathematically, these expressions are all equivalent. Right, this was my original one the first time I did it, again, if memory serves me correct. And then what I did was I told you guys we can simplify radical 44 as radical 4 radical 11, which is 2 radical 11. Then I said if we want, we can go even further and divide out those 2's. Now, again, the reason I'm going into this is if you didn't do any of that simplification, your decimal is going to be the same. Right? In other words, if you put this in your calculator the right way, and we'll talk about that now, versus this versus what we're going to do, you should end up with the same outcome. So what am I going to do? I'm going to put in, I have to do two different things, right? Now I have to actually break down my roots into their individual parts. One of my roots is that x is equal to, so here I should have had x is equal to, I was a little lazy there. Right, so x is equal to 1 plus minus radical 11. So x can be equal to 1 plus radical 11. And x is equal to 1 minus radical 11. So I'm going to put this in my calculator, and I'm going to use the as approximately symbol, right? We are rounding. Radical 11 is an irrational number. It means it neither repeats nor terminates. The decimal goes on and on and on forever with no distinguishable pattern. So that's an irrational number. So we have, just like pi, we have to approximate it. So my best approximation to the nearest tenth, and that's what they're asking us for, and maybe a problem might ask you for the nearest hundredth, but I'm going to stick to the nearest tenth, is 4 3/10. Whereas for the second one, my approximation is going to be negative 2 3/10, and I'm getting that right from my calculator. I'm not doing anything fancy with the radical, and again, whether you use this one, whether you use the other one that I had here, you're going to end up with the same exact solutions, the same exact decimal, which we're going to round in the same exact way. All right, so this is the next one that we looked at yesterday. So when we simplified this, and we couldn't do really a whole lot of simplification, we ended up with 5 plus or minus radical 53 divided by 2. We couldn't simplify radical 53, so this made it nice and easy for us. And that's going to make it nice and easy for us today also. So one of my roots is going to be 5 plus radical 53 divided by 2. And one of my roots is going to be x is equal to 5 minus radical 53 divided by 2. So again, I'm going to put this in my calculator. Now you do have to be a little bit careful with the way you put this in your calculator. Okay, in other words, if you put in your calculator, and I should have said this with the last one, but it kind of just occurred to me now, 5 plus radical 3 divided by 2, it is not going to give you the same result that we have here. Right? So at this point in the class, I'd ask someone, why is it not going to give the same result? And someone's going to raise their hand and say, well, your calculator follows order of operations. So if you had this expression in your calculator is going to do the division first, and then it's going to do the addition, and it's going to give you like 8 point something, which is not correct. So as far as getting the correct result in your calculator, there's two ways that we can do that. One is to put 5 plus radical 53, enter, and then you hit the division sign, and you're going to see on the calculator it says something like ANS. That's your calculator's way of telling you, hey, I'm taking the answer you got from the last problem and I'm doing something else with it. And that's what we want it to do. So you can do 5 plus radical 53, hit enter, and then you hit divide by 2 and it'll do it correctly. The other way to do it, if you want to do it in one shot, is to use parentheses and put 5 plus radical 53 in parentheses and divide it by 2. Again, if you put in your calculator 5 plus radical 53 and then hit the division button 2, it will do it wrong. It will do the division as if that was its own fraction. It's basically going to do this, which is not the same as what we want it to do. So just be careful with that. And again, I forgot to mention that for the first one, so I'm mentioning it here. So when we put this in our calculator, we approximate. We should get approximately 6 1/10. And here we should get approximately negative 1 1/10. And again, if you didn't get that back for the first one, right? Well, the first one, actually, I take that back. That's why I didn't mention it now. There is no fraction, right? So the first one, we actually won't have an issue. This one, we are going to have that issue if we either don't use the parentheses or if we don't evaluate the numerator separately, hit enter, and then do our division step. All right, so there's not really much more to cover. I don't need to do 10 of those. You know, once we've kind of addressed the issue as far as the division with the calculator, I think we're kind of good to go there. So what you would do here is pause it, right, as we always do. And then we come back, and I don't have to go back. We've done, now 4 days of this using the quadratic formula. We're just going to kind of cut to the chase. So for the first one, if you did this correctly, when you're done, you should end up with 7 plus or minus radical 57 divided by 2. So when I split it up, I get 7 plus radical 57 divide 2, and I get 7 minus radical 57 divide 2. So my first solution is going to be x is approximately 7 3/10. And my second solution will be x is approximately negative 3/10. And I'm going to do the same thing essentially for the second one, right? I end up with, I guess I'm being a little lazy here with my x equals 1 plus or minus radical 61 all divided by 6. So now I split it up and I've got x is equal to 1 plus radical 61 divide 6. X is equal to 1 minus radical 61 divide 6. So I'm going to get x is approximately here 1.5, and I'm going to get x is approximately here negative 1 1/10. Now what we're going to notice is if you try to check, is that they're not going to check exactly, right? Because these are rounded to the nearest tenth. That's pretty crude of an approximation for something with an infinite number of digits. So if you check, it's going to be close to 0, right? If you sub in one of these values, it's going to give you something near 0, but it's not going to be right. And if you try it again and you go back in your calculator and you go to the nearest hundredth, you're going to get closer to 0. And if you try nearest thousandth and so on, the more significant digits, the closer you end up getting to 0, but it's never going to check. The only way it's going to check is if you sub in the radical, and we haven't done enough work as far as FOIL with radicals where I think we're ready for that. So for tonight's homework, follow the directions. You are rounding to the nearest tenth, okay? So make sure, just like we are, you're rounding to the nearest tenth. If your answers did not agree with mine in this video, it means that you did something wrong with your calculator as far as the order of operations. Just make sure that you go back and you do it to the point where it does agree with what I have here. And as always, any questions or comments that you have, you can always reach out to me through Google Classroom.